Let me see what you got. You can get up at 8. You have homework. Oh, good for you. She's gonna thank you one of these days. I keep telling my son that. He's 11. I'm like, Zach, trust me, you're gonna thank me one of these days. He says, I don't think so. I'm just gonna wait. When he's 30 years old, Dad, I don't know how to thank you. It's tough love, Kelly, right? It's not mean, Mom. It's tough love. Doing it right. That's right. All right, so this was the synthesis problem. All right, I assume you guys had a chance to work on it. So we'll go over this. So kind of the key things that you want to look for, all right? These are the things that I look for first. Number one, have I added carbons to it? So the first thing, well, I actually look at the functional group first. So anytime I start doing synthesis problems, I look at the functional group. Because usually that's the last reaction, is making that functional group. That's usually, so if you're doing a synthesis, you're saying, all right, what's my last reaction? It's always making that functional group. So I have a double bond. All right, so then I got to think to myself, how do I make a double bond? And go over all the reactions. Basically, the only way to make a double bond in this case is some sort of elimination reaction. Put that, right, E1, E2, something like that. And the only two reactions we learned is a dehydration was an elimination, or an E1 or E2. Let's just put an E2. Okay, so dehydration came from an alcohol. E2 comes from an alkyl halide. So these are the things I start thinking about in my head. Okay. Then I also notice, then I look to see, am I adding carbon, adding or subtracting carbons? Okay, or if I'm not doing anything. In this case, I'm adding carbons. So I know when I add carbons, that's a Grignard, especially since this is chapter 9, a Grignard, or you can do the acetylide. But now that we know about the Grignard, that's kind of the reaction that we'd be doing. So I know I have to add a Grignard because I'm adding 2 carbons. And I know I have to do an elimination. All right, and one of them is a dehydration from an alcohol. And what do Grignards do? Grignards add carbons and they make an alcohol. So when I see stuff like this, I start to put it all together. I realize this double bond came from an alcohol that came from the Grignard. So as soon as you start thinking like that, you can piece it all together. So that means that I'm probably going to have the alcohol here. Now, you could have the alkyl halide if you wanted to. That means I'd have to take the alcohol and then make the alkyl halide. But I'm going to save a step because I know Grignards make alcohols, and I know that the last step is going to have to be that elimination. So that's H plus in heat. And then to make this, I know comes from a Grignard. So that means I'm going to have the carbonyl here, and then I'm going to add the ethyl Grignard. So, GBR. And the second step is add acid. And to add a Grignard, you have to have a ketone. So these little hints kind of help me along with these few steps. Okay? And then you just keep going backwards, okay? To make a ketone, that's going to be an oxidation from an alcohol. And then eventually you can start seeing, wait a minute, a chloride to an alcohol. You can do that in one step. And that's in Sn2, so you add sodium hydroxide. That's in Sn2. Okay, so this is kind of what I'm always doing in my head, or you can write it down, but this is kind of the first part of how I do every synthesis problem. I first think about what's my functional group. Okay, so like if I had an ester at the end of a reaction, let's just say I had an ester as my product. So the functional group's an ester. The very last step is making that ester. What reaction makes an ester? It's carboxylic acid and alcohol. And then, okay, how do I make a carboxylic acid? And then I keep going backwards until, if I have a starting material here, whatever it is, let's just say it's like a double bond or something. All right, so I know that comes from an alcohol, and then, hey, I can go from an alcohol into that with just acid and water. All right, this is like the CrO3. This is just a little thing on the side, but that's basically what I'm doing. I'm looking to see what the functional group is. I look to see if I'm adding or taking away carbons, because that's a huge key. If I'm doing a Grignard, that's pretty much that's like the heart of a synthesis, because that's our transition from how I start at my starting material, at a certain point, and I go to certain ways, and then at the end of our final reaction. Okay? Anyone do something different? Did something different, that's fine. I mean, there's more than one way. Like, you could have eliminated, made a double bond, and then add acid and water to make the alcohol. I mean, there's lots of different ways. This is probably the shortest route of doing it. You could have done the acetylide if you wanted to. You don't have to do that. You could have added the acetylide. Here, let's actually clear this just to show you what another possibility would be. You could, so from this carbonyl, you can add the acetylide. So I'll just add it. Now, this is not a reaction that we have talked about, but I think they talk about it in one of the homework problems. You can treat the acetylide as if it was like a Grignard. It does exactly the same thing as a Grignard. It adds into the carbonyl. And then you just hydrogenate. Look at that. So that would be another way. Again, this is like a Grignard mechanism. Now that you understand Grignards, you can do the same thing for acetylides. So that's another possibility. All right. Questions on that? You guys get that? Is there something else you guys got you want to talk about or anything? Doesn't look like anyone's saying anything, so good. Or not good. Okay. Let's go on then. Let's see. I think we did we do 43, and then I came up with that problem. It was based off of this problem. So it was a little bit more involved. All right, Anna has a question. Question, yes. If you want to go off your mic, ask, that's fine.
Yeah, so it's kind of dealing with like the 1,4 addition.
Okay.
And I was just wondering, whenever you have an alpha, beta, unsaturated, either ketone or aldehyde,
right,
with a primary amine, how do you know if you're going to get an imine or if you're going to do like the conjugate addition?
Right. So it will always do a conjugate addition over the imine. The imine will only occur if you have a ketone or aldehyde. But if you have an alpha beta unsaturated ketone, it's going to always go 1,4.
So that takes care.
Okay.
Okay. And it's because the amine is a weak nucleophile. If it was a strong nucleophile, it would go 1,2. These are thiols stuff. Oh, let's do 53. I like 53. I like these. We'll get these. I can't expand this. Why? This program doesn't let you expand that thing. Oh, cool. Yeah, there you go. Do that problem. Nothing says excitement like sparkles. Yeah, there's grass. I'm just playing around with is fall. It's beautiful outside. There you go. Got some great, fancy, totally fancy. Dodge. It's Dodge. Doesn't even do anything. Oh, look at that. Okay, so to go from the aldehyde to the aromatic alcohol, we're obviously doing a Grignard. So the first step is adding the benzyl Grignard, or not the benzyl, the phenyl Grignard. This would be a phenyl Grignard. And then the second step is adding acid. Let's get that. And then to get to the ketone, you have to oxidize this. So you can either use PCC, or PI, or in this case, since it's secondary, you can add like the CrO3 in acid or the Na2, CR2O7 in acid, and those. To get the metabromine, that's chapter 5 stuff, the aromatic, so Br2 and FeBr3. And then this is the acetal. So 2 equivalents of CH3OH in the presence of acid. Okay. All right, so any questions? All right, let me see what Abby says. Sorry, my mic isn't working. You're feeling the last question. All right, yeah. I can do that now if you want. So, Abby, I imagine everyone's seeing that. Abby wants to know the very last question on the exam. So we can go over that now. I'm fine with that because that's, you know, you could have actually done it chapter 8 ways or chapter 9 as well if you wanted to. Are you saying about the synthesis problem? I assume that's the synthesis problem that you're talking about. Yeah, okay. Let me just refresh my memory. Because there are 2 ways. You could have either done it using a Grignard, or you could have done it with the acetylide, I believe. Let me just double check. Yeah, so it's the chlorine to an aldehyde. I'm actually looking at it. I think I might have... Oh, no. Never mind. Got it. I thought there was something else that I was going to do. Okay, so we're going starting from the chloride. I did it a really bizarre way, not sure if I made any sense. All right. With the Grignard, it's like 2 or 3 steps if you did Grignard. So going backwards, so I'll do it with the Grignard, but you didn't have to do a Grignard because technically the Grignards were chapter 9, but you guys already knew about Grignard, so if you did a Grignard, that's totally fine. So again, going backwards, like I said, the first thing to do is look at the functional group and think to yourself, how do you make that functional group? So the way that you would make that functional group would be from the alcohol. Start with an alcohol and oxidize it with PCC or PI. I don't think it would matter which synthesis you did or which route. This would have to be the last step. There's no way to put on just the aldehyde group on something like that. You have to start from the alcohol and do it. So if you do it from a Grignard, you would add, like I said, there's probably, I can think of 3 ways just quickly off my mind of how to make this. MG, you make that a Grignard, add formaldehyde, and then add acid to it. Is it okay to use nitrile? Yes, that would be a 4th way. I didn't think about that. But yeah, absolutely. Yeah, I mean, again, even though it was chapter 8, if you did chapter 9 and 10 reactions, I'm totally fine with that. Because at this point, you know all those. So I'll go over that way too. So this is one way. Make the Grignard, add it to formaldehyde, you get the alcohol and then PCC. Another way would be to take the Grignard and just add just add this ester to it. One equivalent. So that's the reaction in chapter 10. One equivalent of an ester, remember, will add into here, and this group is a leaving group. It will leave, and will make the aldehyde. So you could have actually done it in 2 steps. So that would be another way of doing it. The other way, which is the nitrile, which I didn't think about, so very good. Luke and Kelly for doing the nitrile. Because we're only adding 1 carbon, and then you hydrolyze it with the sodium hydroxide and acid. Again, this is chapter 10, which, that's awesome if you did it. We give you the carboxylic acid, but then you would have to reduce it with LAH to go down to the alcohol, and then you'd have to oxidize it back up. So that's the only thing. You'd have to reduce all the way down and then oxidize. And then another way would be to add the acetylide. So if you want to do chapter 4 reaction, add the acetylide to it, which would give you 2 carbons, triple bond 2 carbons. You would have to do Lindlar's. Sorry about the small writing. I think you guys get the idea. You get the double bond. You then would have to cleave it. And if you cleave it, it brings you down to this, the carboxylic acid. So cleave it with potassium permanganate acid. And that would be another way. So it's that 1, 2, 3, 4, 5 ways. Let's see, 1, 2, 3, 4 ways. Okay, I did the last one. Abby did the last. Oh, with the acetylide? Is that what you said? You did the acetylide? Yep, it's totally fine. Yep, good. Yeah. So, I mean, if you see at this point, you know so many reactions. There's so many different ways of doing this now. Good. Sounds like you guys did good on this one. Maybe on the next exam I'll say, synthesize this, show me 3 different routes. That would be fun, wouldn't it? I can hear the swearing now. Even though everything's muted, I can feel. You guys would be like, I'm going to take him at the tiger park. No, we didn't feed him to the tigers. All right, good. So look at that. That was good. It's actually a good review too of some of that. All right. What I wanted to do, I think that was pretty much the other ones. I was going to look at some of the. Let's look at some of the problems on the problem sheet. Have you guys had a chance to look at the problem sheet for this chapter? Get to it real quick. Problem sheets. I think I posted just the sheets, right? I think. Yeah, this is chapter 9. Just the answers. Let's see. Yeah, I pulled these up yesterday. I think chapter 1. Page 1 is just naming. How do you synthesize? Yeah, I think we should get to the more complicated ones. I think you guys. All based off the people who are answering in here and stuff. Looks like you guys have a good handle on it. If I don't hear from you, it's hard for me to gauge what's going on. That's the one thing about doing the online. Usually in class, I can read the class, but online, obviously, I only see the like the same 5 people. So if you are not getting it, don't make sure you speak up and tell me you guys are doing all right. If you want me to go over everything, let me just download this. All right, let's do some of these synthesis problems since we have them here. These are pretty good ones. We have about an hour, so let's see which one. Let's do a good one. Let's do one. Yeah, let's just do these bottom three. Oh. Okay. So let's do these three. Try to come up with as many ways as you can do it. Okay, that's really good practice. I was just kidding. On the exam, I'm not going to ask you to show me, show me different ways. However, what I might say is your synthesis has to include a reaction from chapter 10, or it has to include a Grignard reaction, or it has to include, something like that. Or you can do this, but it cannot have an acetylide ion, like something like that. Try to do these using chapter 8, 9, and 10 reactions. Now, I try to make problems where you have to use those, but I might force you to actually just do those. So try to do them as many ways as you can, either chapter 4 reactions, and then also see if you can just do chapter 8, 9, and 10 reactions, just for the practice. This last problem, both of these carbon sources have to come from the same compound. Okay, so I think we've seen a question like this where you have two different starting materials, and you have to show me how both of them are incorporated. Well, technically, you have two of these. You have to show me how both of them are used in order to make this. Okay, obviously, I'm taking like two of these, and somehow I'm joining them all together. So that's what I want you to show me in that last one. So that last one has two pieces. I have to show you how to synthesize this piece of it and that piece of it, and eventually I have to join those two all together. But they both have a starting point of this. Does that make sense? So I'll let you guys work on these for a while. Again, the first thing that you want to do, the strategy, is what's your functional group? That's where you want to start, functional group. Okay, look at the functional group and think to yourself, what reaction have I learned that makes that functional group? And that's your last reaction. That's how you know what the last reaction is. And then think to yourself, am I adding carbons? Am I taking away carbons? Do I have the same amount of carbons? Because based off of that, we'll tell you if you are going to be doing Grignards or acetylides or anything like that. If you have to do a Grignard, then you know an alcohol is involved. An alcohol is kind of a central functional group. You can pretty much get to any functional group from an alcohol. So once you get to an alcohol, you can get to anywhere. You can get a double bond, you can get alkyl halides, you can get carbonyl compounds, you can turn into an ester, you can turn into a aldehyde, ketone, you can turn it, or if you want to, you can turn into an alkyl halide and then do any type of Sn2 reaction on it. So alcohols are really a central functional group. If you can make something into an alcohol, that's really what you want to get to, because from there, you can get to anything else. All right, actually, you know what? Since we're talking about it, let me see. I might have this thing posted on here. I usually go over this in class. We talk about it in class, and it's usually one of the labs. But since we... here it is, the reaction flowchart. I don't know if you guys have looked at this. This is kind of a... I don't know what I have here. If I have the student version or the... No, I have the book one. Man, that's upside down. All right, this is kind of a, this was in the old edition of the book, and it's kind of a flow chart to show you how you can get from functional groups. So let's say you want to synthesize a carboxylic acid, which is right here, all right, where we see the carboxylic acid, and let's say you're starting from an alkyl halide, okay? Well, how do you get to the carboxylic acid? Well, if you follow the route, you can usually follow the route. This is not set up that great, but technically you can go from an alkyl halide to a double bond, and then to an alcohol, and then to an aldehyde, and then to a carboxylic acid, or you can go to the alcohol straight to the carboxylic acid. It's not organized that well. I actually have a student who made one. I don't have a copy of it on here. I usually show you guys in class. It's a poster that has all this on there, and it kind of has it organized. It's just kind of a flow chart. So if I start with a triple bond, how can I go from a triple bond into an aldehyde? well, triple bond, double bond to an alcohol into an aldehyde. So it kind of gives you the flow of things. And again, in class, I usually go, it's hard to do now because we don't have the class to do it. But that's kind of what you want to try to do with these. I have a double bond. Oh, what I wanted to show you is that the alcohol, which is right here, you see how there's alcohols here, is really our central functional group. All right, I can turn any of these groups into an alcohol, and then from an alcohol, I can go from there and turn it into any of these. So everything on this side is chapter 4, right? All the double bonds and triple bonds is chapter 4. And then really chapter 8, 9, and 10 is all about all the carbonyl compounds, which is right here. So, and the alcohol is kind of our central thing. You can go from a double bond to an alcohol, to a triple bond alcohol, to an alcohalide into a double bond, into an alcohol. And then from those, you can go into a aldehyde, a ketone, carboxylic acid, which then you can eventually get to acid chloride, anhydride, all the other stuff. So alcohol is really what you want to try to get to. That's really the strategy of this. So if you see this, right, can you make a double bond from an alcohol? Yes, in one step. So that's probably what you're going to want to do. All right, how about a ketone? Can you make a ketone from an alcohol? Yes, you can. All right, here's another ketone. Can you make it from an alcohol? Yes, you can. So once you get to this part of the graph, are you going from this way, that way, or are you starting here and going that way? That's kind of what you want to start thinking about. Okay, so like I said, in class we go over more, but hopefully that might kind of give you a little hint now. It might not be as lost, all of the reactions. If you have them organized like this, it might help you quite a bit. So your double bond to an alcohol to a ketone. All right, yes, it could be done. It is helpful, Morgan. Okay. So hopefully try to think about this chart and try to think about this as our central point. You're either on this side with these compounds, which are basically chapter 4. This is all the stuff we learned in chapter 4, double bonds and triple bonds. And then here's all the stuff we learned in chapter 8, 9, and 10. And then aromatic is kind of its own thing. That's why it's kind of all by itself. It's not really tied into any of this. It has its own reactions. Okay? So I'll let you guys kind of play with that for a little bit. Okay? Okay. You'll be able to upload a picture of the student. It's in my office at work. It's a lot easier and it's very detailed. It's unfortunately at work. I'll see if I have it on my external hard drive here because it's a pretty big file. But there's probably there's a 5% chance I have it here. Otherwise, I won't be able to do it. Okay. Yep. Okay. So I'll go on pause and let you guys work on that. Okay. So for the first one, it's a double bond. Here. So, alcohol. Well, so to make a double bond, again, either dehydration of an alcohol or an aldehyde. All right. And so then I kind of look at the starting material and then try to think about, do I need to add carbons or remove carbons? Because again, remember, adding carbons is a Grignard and it makes alcohols. If I have to remove carbons, that's oxidative cleavage. And remember, oxidative cleavage also leaves oxygens. It either leaves a ketone or carboxylic acid. And notice, I am going to have to do oxidative cleavage. I have to remove this carbon. So since I'm going to be doing oxidative cleavage and I know that I get a carbonyl, I know that I'm going to have an oxygen here. So that's the strategy that I'm going to go with. So you see how doing stuff like that, just those two questions with every synthesis problem will really get you pretty much most of the way there. And then, so since I know I'm going to have to do oxidative cleavage, that means I'm going to have a carbonyl. So this is either like sodium borohydride or LAH, either one in this case. And then to do that is going to be the oxidative cleavage. Okay, that's the first one. Any questions on that? Okay, next one. Again, start at the end here. We have a ketone. An aromatic ring. Now, there is a reaction that you can form this starting from a benzene ring. If you take benzene, you can do the Friedel-Crafts acylation. So if that was the route that you were thinking of, that's great thinking. You could do this. However, notice I have a bromine here. If I didn't have a bromine there, if I just had benzene, that'd be it. One step, you're done. However, I have a bromine. So I cannot do that reaction. See, so like something like this is showing you how I'm forcing you to do a very specific reaction. If I didn't have that bromine, you can do that and you're done. However, just keep things like that in mind, saying, oh, he's a bromine here. Don't just think, well, I'll just do it and hopefully that bromine vanishes. Don't think that way. All right, think, there's a bromine there. It's not what we learned, so he's probably trying to get me to do it a different way. All right, and the answer is yes, I am trying to get you to do it a different way. I'm trying to get you to do it as a Grignard. Okay, so ketone, how do you make a ketone? Well, you can start from the alcohol. That's one possible way. And you do PCC or PI or the CrO3 because it's a ketone. All right, and then you get the alcohol. You add it to the Grignard. Okay. Another way would be, rather than adding the aldehyde, add the ester. And this is a chapter 10 reaction, but add 1 equivalence of the ester. And you can get that too, so that's another way. And then to get to the Grignard, you just add magnesium to it. All right, so Grignard plus the aldehyde gives you the alcohol, oxidize it to the ketone. Okay. Questions on that one? Before I delete it. Okay, and finally the last one. So both of these groups have to come from the same part. So, once again, what do we have? We got a ketone. How do you make a ketone? You can cleave it, oxidative cleavage, but notice I'm adding carbons. I got to join them together. So again, that's a Grignard. I'm hoping you're starting to see a theme here. PCC. So how do I form this? Well, you got to start from this aldehyde, and then you got to add it to this Grignard. And then the second step would be to add acid. So those are the two pieces. So now I got to show how to synthesize both of these starting from this compound. Okay. So let's start with this one. I have an aldehyde. It's on this carbon. It's on the outer carbon. I have a carbonyl. So that means I have to get an oxygen. So again, what's our central group? Alcohols. I can make this from an alcohol. All right. The alcohol that I would be able to make it from would be that alcohol. PCC or PI. Okay. So how do I get this alcohol from this compound? Notice it's a least substituted alcohol. So it's BH3 into H2O2 and sodium hydroxide. And then to make this compound, this is a Grignard. Notice I had to cleave this carbon off. So in order to make that, you got to cleave it. So potassium permanganate and acid to get the carbonyl. Carbonyl, reduce it with LAH or sodium borohydride to give you the alcohol, And then I'm going to do like 2 steps at once here. One would be to turn to the bromine with like PBr3, and then 2, add magnesium to it in order to get the Grignard. All right. But I hope you notice, every case, let's bring this thing up again. In every case, what am I doing? I'm getting it to an alcohol. I'm getting it to this. And then basically, once I get it to here, I can pretty much see how it'll either start from here or go to here or start from here and go to there. Right? In order to go from here to the alcohol, it's LAH or sodium borohydride. To go from here to here, I got to oxidize it. So they kind of show you that. You see how right here is an O and right here is a hydride? Right? So let's see. Kelly said, can you also use this? Yeah, oh yeah, sure. I mean, I just made it into a bromine. You can make it to a chlorine. You can make it to an iodine. Yeah. Any halogen I use, you could use any of the other halogens. But, you know, like I said, I always do bromine because bromine is the, I think I told you guys, is the Goldilocks of halogens. It's not too fast, it's not too slow, it's just right. Okay, but for those of you struggling with synthesis or doing these, does that maybe help you to see these a little bit better, knowing you have to probably go through alcohols, or alcohols can drastically help you on how to do this? If you know you're trying to get to an alcohol, that's kind of half of the battle. Okay, good. All right. Yeah, I usually say this lecture for now because now we have every reaction and we know how to make all types of alcohols. So knowing how to make every type of alcohol is probably one of the key things. So maybe make a piece of paper. Actually, why don't we do that right now? Let's do it all together since this is review. So like on the center, also this is something else I tell you guys to do, but you guys have all your notes. But if you want to organize your notes a little bit better, I would have on a piece of paper or a flash cut or something how you make a specific functional group. So on a piece of paper, in the middle, have, I don't know, an alcohol. Oh, no, that's not what I did. So either have the word alcohol or, I don't know, or, you know, whatever, alcohol with OH. And then think of every possible way in order to make an alcohol. So why don't we go over that? One way is to take a double bond and add acid and water. That makes an alcohol. Another way would be to do the anti-Markovnikov, BH3 and H2O2 and sodium hydroxide. That's another way. Another way would be an Sn2 reaction, so hydroxide. Another way, so you guys remember when we did chapter 4, you remember I passed out that sheet where it had a double bond in the middle, and then it had all the arrows all coming out of that, and it had all the products around it. You guys remember that sheet? This is kind of the same thing, except all the arrows are going in the middle. I'm showing how to make the same functional group over and over again. I'm starting with all different stuff. Another one would be a ketone or aldehyde. So you can put C or H here. So that is sodium borohydride. Another way would be from the ester or the carboxylic acid. So O, R, or it could be an H, and that is LAH. Another way would be a Grignard. So a carbonyl compound of some sort and adding a Grignard. So RMGBr. 1, 2. So many reactions there are for alcohols. I don't know. You guys tell me anything else. Another one would be a diol. You can talk about this. Diols, either they came in 04, even though it's not a monoalcohol, it's a you know, that'd be a cis diol. You can put it on this page or on a separate piece of paper, or you can put like diol right here if you wanted to. Cis diol. We also learned about trans diol, the epoxide. Any other ways you guys remember? I think that's pretty much most of them. I don't know if you guys can think of other ways, but this is basically the exercise that we do in class on one of the labs. That basically you guys will get in groups and brainstorm, think what reactions, and it organizes it. Rather than just having this obscure reaction, BH3H2O, it shows you kind of where it fits in. And then you can go back even further. Well, how do you make an alkyl halide? And keep going. Well, alkyl halides can come from a double bond, an HCl. It can also come from an alcohol, so you can maybe draw the arrow in reverse that way and say SOCl2. Right? So, can you do a hemiacetal? Well, I mean, if you wanted to, but a hemiacetal is a hemiacetal. It's not an alcohol. I'm just strictly trying to show an alcohol as a functional group. So a hemiacetal is like a hemiacetal functional group. It's not an alcohol. So yeah, so I mean, I wouldn't include that, but if it helps you in doing that, it's totally fine. Like, there is no really absolute right way of doing this. It's just whatever makes sense for you. And then you just keep going backwards. So how do you make an aldehyde? Well, obviously from the alcohol, so I can go that way and do like PCC. But is there any other way that we learn how to make an aldehyde? I don't think I can think of any. But a ketone, I mean, if we have a ketone here, a ketone is a double bond in oxidative cleavage, KMNO4 and acid. Here is a carboxylic acid. How do you make a carboxylic acid? Well, you can oxidize the alcohol with the CrO3 and acid, or again, you can do oxidative cleavage, a double bond with KMNO4 and acid. I'm kind of writing small here. I'm just doing it quickly, just to kind of show you how all this ties all together. Double bond, how do you make a double bond? Well, there's two ways. Either from an alcohol, right, elimination, so you can do it here from an alcohol to a double bond, or an alkyl halide, so alkyl halide into butoxide, or you can go the opposite way, so go like that, and that's acid and water as well. Right, so what I'm trying to show you is, notice almost every reaction that we've talked about so far is kind of already on here. Right? I'm just constantly all going backwards. How do you make a double bond? Well, it's from a triple bond. And Lindlar's. Right? So you've already made a chart here. So if I want to make an ester, okay, I'm sorry, if I want to make a carboxylic acid from a triple bond, Lindlar's to the chloride to the alcohol and the CrO3 and the acid. See how it all ties all together? So basically this is the chart I just made. So that chart, you guys at this point, you should kind of make your own chart, but kind of showing you how the alcohol is kind of our translator in a way. So in doing something like this, if you do this on your own, and just exactly how I did it, and you fill in all the reagents and start seeing how this goes in, this makes synthesis so easy. I can give you any problem. It won't matter what the problem is. You basically just keep doing this. It's basically this in problem form. Okay? Let's see if there's another problem. You guys can kind of practice doing this. How about this one right here? This is a great one. Right there. So take everything I just said and apply it onto this problem. All right. I'm going to erase this, but I think you guys get the point. Okay, so here's your starting material. Start here, go backwards. Carboxylic acid, how do you make that? Also, are you adding carbons or are you taking carbons away? And then just keep going. Try to think about where the alcohol point is. And there are times that you might make alcohols more than once in the same synthesis. You might not make an alcohol only once. You might need to make it twice at certain points, or 3 times. Okay? So I'll give you guys another few minutes. Hopefully, maybe using that chart will help. I'll go on mute. Okay, so carboxylic acid comes from an alcohol. That would be the alcohol. And you'd have to add the CrO3 and acid. All right, notice we are adding carbons. We're going to have to add a carbon. So that's a Grignard. Grignards make alcohols. So that's my Grignard step right there. So I'm going to have to start with this. And whatever, MgCl, MgBr, whatever you guys want to add. And then one carbon, acid. Hold on one second. Oh, no. I drew that wrong. That's what I was like, that isn't right. It should be right here. MgCl. Because I'm putting on that carbon. That's the carbon I'm putting on. So it comes from that carbon. So to get this, I have to turn this into a chloride. So HCl. And add magnesium. Okay. Okay. Again, see how this, and if you go back to that flowchart thing, you can see we're starting at a double bond. Where's the bond? Alkene right there. Alkene to an alcohol, but I'm actually going to the alkyl halide first to the alcohol. Again, this doesn't have it perfectly organized, but you can organize it in a way in order to do it. Okay. Questions? You guys get it? Making that chart, making it a little bit easier to see. Okay, good. All right, so yeah, so like I said, a good practice would to just have a functional group. Just put a functional group and just try to write as many reactions as you know in order to make it. Like I said, alcohols pretty much can come from every functional group. But then how do you make those functional groups? How do you make alkyl halide? So you know, have an alkyl halide as our central theme, and then how do you make all these? Well, I think there's only really two. It's that one or an alcohol. That's a Cl2. And you can do it on an aromatic ring, but that's a special reaction. So there's only really two reactions that make an alkyl halide, depending on where that you're starting from. How do you make an ether? I have an ether here. There's only one reaction we know that makes an ether, and that is an ether, a Williamson ether synthesis. So then go backwards there. How do you make those? This is with sodium metal, and hey, look at that, an alcohol. All right. How do you make an alkyl halide? Well, we already saw right here, alcohol or an alkyne. I'm sorry, an alkene. So when I was like taking organic, when I was in my study group, this is what we used to do. Every person would get a chance and put a different functional group on the board. And what we'd have to do is, so if we put this on the board and we did from an alcohol, then we have to go back again. How do we make the alcohol? All right, and then how do we make that? How do we make that? And we would keep going back until we eventually made it back onto everything else. So how do you make an alcohol? Make it from a double bond. All right, or split off and make it into an alkyl halide. And you just keep going. And that was kind of our practice. And you'll find out that's, once you get the alcohol, you can get it from everything. All right? All right, hopefully that helped today. I think it did. That's usually my alcohol lecture. Usually a lot of people start seeing the light after they have the alcohol lecture. That can mean more than one thing, can it? So, with that said, I would work on the review sheet. The exam is tomorrow for this chapter 9. Like I said, if you want to, obviously if you want to use chapter 10 reactions in it, that's fine. But basically, it's going to be geared towards the chapter 9 homework stuff that we've done and those types of problems. Okay? Anything else? Otherwise, we'll call that a day. You guys did a good job, as always. Yep, Anna, no problem. You're welcome.